Right. Let me share my screen. Okay. So we were talking about, so the SQL operating system, right? UMS. Earlier we used to call as UMS, user mode scheduling. So later it changed as a SQL operating system, SOS, right? SQL operating system. Uh, so this we talked like how the request will be handled, right? So this is the high level, so understanding. Whenever there is an incoming request and it will be assigned, it will be checking if there is an available worker is available or not. If it is available and assigning, and it will be in the runnable queue. If worker limit is reached, if not available, checking worker limit is reached. If worker limit is reached, it will be waiting for worker to be available. It will be the status will be in the pending queue, pending. Then it will be waiting for worker to be available. Then it will be creating worker if the worker is limit is not reached. Then a worker will be created and assigned task to the worker. Right. So this is how that handles the request. This is high level, so I don't think it is required. Let's go with wait statistics. Right. So so what we mostly bother about, like, so the whenever there is an issue, right? So whenever there is an issue and customer says the query is running slow, customer says that application is running slow, right? So what do you mean by slow, right? So we should understand what does it mean by slowness, right? How you will understand whether it is slow or not, right? So it depends on the word baseline, right? What is baseline is how much time it used to take. Let's say the performance is slow. So on what basis he was telling slow? Is it like referring on this server or referring some other server and saying that slow is what he is she, right? Uh, So on what basis they were telling it is slow, right? So first we need to understand what is the baseline of that particular issue, right? Earlier it used to take 1 minute. Now it is taking around 10 minutes, right? So this is the baseline, right? So this is the baseline. Like earlier it used to take 1 minute, now it is taking 10 minutes. So this is the baseline that for this particular issue or for that particular query. Okay. On the same server, remember on the same server, let's say someone comes in and asking, telling that like, so this one is one VM. This is another VM. They might tell that, okay, these two are identical configurations and all, but this machine, it is taking 1 minute, and this is in this mission, this is taking 5 minutes, let's say. These two cannot be comparable, right? So cannot be comparable because one sec. These two cannot be comparable because this mission hardware is completely different than this mission hardware. This mission cache, plan cache, everything can be different than this. Yeah, not can be. So the cache will be different than this. Optimizer generates a plan might be different, right? Everything would be different. So what we need to check whether the data is same, whether so both are identical with respect to the query, with respect to the what hardware components, everything, right? So we'll have to see. In case everything is identical, even data is identical, the workload is identical, maybe we'll have to check like why it is taking so longer on this machine, right? This is the baseline, right? So define, right? So in simple words, like a define of a fast query, right? So if someone says that like, so earlier it used to run faster. What do you mean by faster, right? So without any metrics, if someone says that it was running faster, it was working way better than this, like we cannot tell or we cannot confirm that what does the word means faster, right? So we need to know the metrics, right? Metrics as in like how much time it used to take and how much time it is taking now, right? So baseline acceptable execution duration established during the development and testing, right? So this is what the baseline is. Right? So this we already discussed, like what is the query life cycle in a simplified. So suppose if the query is running on the CPU, it will be in running state. If the query is waiting for resources, yeah. So query is waiting for resources, it will be in a suspended state. If query is query has all resources it requires and waiting for CPU to be available. When the CPU will be available, if no threads are currently running on the CPU, then CPU would be available. Then it will be in the runnable queue, right? So I told you like signal wait time. Basically, who is giving signal? The thread which is currently running on the CPU that will send give a signal to the thread which is in the runnable queue saying that I am coming out of CPU. So the next thread or the first thread in the queue should go and run on the CPU. So that is that signal it will give to the thread which is in the runnable head of the runnable queue. Okay. So this is for the waiting for CPU, waiting for some resources. This is the actual execution time. Actual execution time is the time when it is running on the CPU in a green um, color coded, right? So this also we talked about the high level. So the session first, so whenever user, connected, a session will be created. A session will be created and then a request will be assigned to a session, like so user request will be assigned to a session. uh, that request will be a kind of so task that will be creating a task and the task will be assigned to a worker, right? So the request is converted as a task, right? So a session will be created as soon as you open this one. mm, right? A session is created, 51 session. Let's say if you see here down, right? A session will be created. Then a request, so user requested, like either it can be select or whatever it is, a request will be assigned to a session, right? So a request is converted as a task because the worker will be assigned to a task. Task will be assigned to a worker. So the task will be assigned to a worker and the worker will be executing on a scheduler, right? So this is a high level, so whatever it is. A session is the connection a client has the SQL Server is connected to, right? After it has been successfully authenticated. So if you remember, okay, so if you remember, so as soon as I wanted to open a new connection, right? It is asking for me to authenticate, right? It is asking me to authenticate because as soon as I authenticated, then only a session will be created, right? Authentication is nothing but making a connection to the SQL Server, right? So a session is the connection a client has to the SQL Server it is connected to after it has been successfully authenticated. We can easily access session information by querying the DMV, right? So select star from sys.dm exec sessions, right? Sessions. How to check the exit current session is where session ID equal to edit session. Sorry, at a speed and execute. You will see the current session information, right? Session ID equal to edit session, right? You will see the session information in a high level. So DMV, dynamic management view, right? So DMV, the data that we execute or the data we get from the DMV is from the memory or from the cache that we have on the SQL Server. So DMV data, whatever we execute or whatever we get, everything is stored in the memory. As soon as the connection is closed or as soon as the memory is flushed out, everything will be removed from the cache, right? So that is the reason if you restart the SQL service and if you try to execute any of the DMVs, you will not see anything other than the particular session, right? So there are background sessions. So I'm not worried about background sessions and all. And if it is especially a user sessions, it will not be available if it is so if it is DMV and executed after the SQL restarts. Request. A request is the SQL Server execution engine's representation of the query submitted by a session, right? A request is basically I'm executing a select statement. So that will be considered as a request, right? Uh, I'll just go here again, select star from sys.dm underscore execute exec request, right? Select star from sys.dm exec request, executing request, where session ID equal to edit speed, right? So it will tell the current executing request, right? Where, right? There are few other background threads where it is running. Okay. A request. So a request is the execution engine's representation of a query submitted by a session. Okay. A task. task represents the actual work that needs to be performed by the SQL operating system. So as I told you, right, request will be assigned to a task, right? A task will be created and request will be assigned, but they do not perform any work themselves, obviously, because task is nothing but just a so assignment before even it is handed over to the thread. When a request is received by the SQL Server, one or more tasks will be created to fulfill the request, right? Let's say the SQL is received a request from the application, right? A request can be assigned to multiple tasks. One request can be assigned to multiple ones. Sorry. So one request can be assigned to multiple tasks. This request can be kind of bunch of queries, kind of stored procedure, kind of multiple queries, whatever it is. Or request can be a parallel execution, right? So anything it can be. This will be okay. Um, but they do not perform any work. When a request is received by the SQL, one or more tasks will be created to fulfill the request. The amount of tasks that gets generated for the request depending on the query request is being performed using the Go. This is what I was talking. Parallelism, or if it is being run serially, right? We can use the DMV again. So there is another DMV to get that information. Select start from sys.dm os task, right? It tells that what are all tasks which were created, right? So what were all tasks which were created? What is the current task state, right? Either it is suspended, waiting, running, runnable, done, whatever it is that we see here, right? So there is another, um, I would say, system DMV, I mean DMV to get the information of about the task, right? DMV to query the task information. Then finally, a worker. Worker is what we already talked, right? Worker is the base unit, basic, smallest unit of your execution, right? So where it takes the worker, I mean, a worker will be, a task will be assigned to a worker and worker will be executing on the scheduler. Worker threads are where the actual work for your request is being performed. Every task that gets created will get a worker thread assigned to it, right? And the worker thread will be performed an actual request by the task, right? Whatever task that is generated, it will be assigned to a worker. Worker will go ahead and execute on the scheduler, right? So this is the overall. Now let's move on to the weights that we were talking. So what does it mean by wait, right? What is running and waiting, right? Let's say, for example, select query, select start from table, and user complained that this query is taking 10 minutes to execute, right? So 10 minutes execution is what we call it as a total duration of the execution. Total duration. So total duration including the currently running or running and waiting. Okay. So including everything, it considered as duration, right? Let's say the query is actually taking 1 minute to run, right? So currently actually taking 1 minute, it spent 1 minute on the CPU. Remaining 9 minutes, it is waiting for some resources. Let's say blocking or lock, right? Then this is not considered as running query. This is considered waiter query because the query is taking more time to get the resources it requires, right? So this is the difference between run and wait, right? Run is actually running on the CPU. Wait is basically waiting for some resources, right? Query worker thread running on the CPU, right? So it can be a compilation. I told you earlier, right? Even compilation, it takes us some amount of CPU cycle. So if you have a high number of compilations, we will talk about CPU troubleshooting. But if you have a high number of high number of compilations, then number of I mean, like a high number of compilations compared to number of batch requests, then the CPU usage would be high. Second reason is execution. The query itself is taking time to execute, then it will be a high CPU. I mean, sorry, it will be considered as running. The query is running. What is the wait, right? Wait is nothing but it is waiting for some resources. The resources can be one of these, not limited, can be any of these and can be more as well, right? It can be a lock, it can be an IO, it can be a network, memory, latch, whatever it is, and it is waiting for some resources, right? Is called as a wait. Suppose, as a previous example, right? 10 minutes, only 1 minute is took on the CPU, remaining 9 minutes, it is waiting for some resources. It is waiting for some resources. Then investigating or checking the query execution plans and all doesn't require because it is waiting for some resources. We need to understand why it is waiting for some resources and is there any way we can eliminate the resources, right? So is there any way we can reduce or eliminate the resources? That is something that we will have to look into, right? Let's understand few terminologies that we have. So wait time, thread is waiting for some resources and cumulative wait time, right? So wait time is thread is waiting, basically waiting currently right now. Cumulative wait time, it tells that wait time since the SQL service is restarted, right? So cumulative wait time is since the SQL service is restarted. So where we can get that cumulative wait time? Yesterday I was talking sys.dmos wait task and waiting task, right? There are two DMVs that we select star from sys.dmos wait stats, select star from sys.dmos waiting stats. So this will tell what is the current waiting queries. This will tell what is the cumulative waits since the SQL is restarted, right? Cumulative wait since the SQL service is restarted. Okay. Signal wait time. Signal wait time, a thread in the runnable queue waiting for CPU cycle to execute, right? Who is giving that signal? Signal will be given by the thread which is currently running on the CPU. Currently running on the CPU, it gives a signal to the thread which is in the runnable queue, right? So you remember what is runnable queue? Runnable queue is basically a uh, queue which has threads, right, ready to run on the CPU. those are not waiting for any resources. It is currently in the runnable queue and ready to wait for a signal so that it go ahead and execute on the CPU. Total waits, right? So total waits are wait time, that is waiting time for resource, plus signal wait time, the runnable thread wait time, right? So the total wait, the wait we will have to consider is the resource wait time. Let's say, for example, a thread. Let's go back here.
So sorry, can you explain the signal weight again?
I will explain. This is on the CPU. A thread is currently running. Okay. Thread is currently running. And this is a SQL operating system. We have a runnable queue. So what is runnable queue? Runnable queue are waiting. It is not waiting for any resources. It is waiting for CPU to be available. When the CPU will be available, whatever thread which is currently running on the CPU, it should go out of CPU, and a thread which are there in the runnable queue header, right? This is one thread, this is another thread, this is another thread, right? Multiple threads that you have, workers. And currently there is a thread running on the CPU, right? So when the CPU would be available, if this CPU, as I told you earlier, right? So only one thread at any given point of time will go ahead and execute on the CPU. If current CPU is busy with this particular thread, all these threads in the runnable queue will be waiting for the CPU to be available. Now let's say this thread, which is currently running on the CPU, has to come out of the CPU so that it will be allow the thread in the runnable queue go ahead and execute. So how this thread in the runnable queue will understand I'll have to go and execute at what time? It doesn't know. When to execute, it doesn't even know. So whatever thread which is currently running on the CPU, it give a notification to the thread which is in the runnable queue, the first thread in the runnable queue. That signal or that notification is called as a signal. It gives a signal saying that I am coming out of CPU. You go ahead and execute on the CPU. Otherwise, I am coming out of CPU. You be ready and go ahead and execute on the CPU. That is what it is, the signal.
So can I quickly just understand what you don't mind?
Mm-hmm,
So let me just to my understanding now is like this is a restroom. The CPU is the restroom. So if
mm,
I go into the restroom, once I bolt it, there's a sign that is outside that shows you that occupied.
mm,
So that means that I am inside. So once I'm done, I open it. That sign now shows that it's empty. So for
mm,
the next person, so that is a signal that the next person can go in. So when the next person is done and then go in and bolt it again,
mm,
that means the CPU is occupied, the restroom is occupied.
mm.
So when finished, the next person, as you open it, the next person goes in and use it. So that is how it goes. I don't know if I'm understanding. That's what
Yeah,
I'm trying to say. Yeah.
that is correct. That is correct. Yeah.
Okay. Okay. Thank you.
That is correct. Because like
Okay.
when you are in the restroom, like so everyone outside, so it will be in a queue, right? So
Mm,
only one
mm,
person can go inside and so use the restroom, right? So
mm.
other persons will be in the queue. That
Oh,
understanding is correct, and it is basically a classic example that we usually see. Yeah, correct.
oh, okay. All right. Thank you.
Right. So this is what we call it as a signal wait time. So how long this thread is waiting uh, for this particular query to for particular thread to give a signal, right? So that is what it is, the signal wait time. Okay. So total wait time is again okay. So let me add this clear. Oh, I'll put this. I'll go a step back with this diagram. So if you remember, right, waiter. So this is the waiter list. The thread is waiting for some resources, right? So this is the runnable list. The thread is ready, available to run on the CPU, right? It's a kind of, so restroom and, so waiting for, this is available. People are waiting for this is available in the queue. Whoever in the first, they will go and use the restroom, and whoever in the list at the end, bottom of the list, they will have to wait for the person who is using the restroom come out of so the restroom, right? Now let's say here it is waiting for some resources. Let's say it is waiting for some lock, right? It is waiting 1 minute. The thread is waiting for 1 minute to get the resource, right? It got the resource, then this thread will go back and run and on the queue, end of the queue. So it end of the queue when this person will get an opportunity or will get it's time to use the restroom, or when this person will get a time to execute on the CPU, right? So that it can be, it will be after the previous threads gets executed, right? So now this thread is kind of, so waiting for uh, 2 minutes, let's say, right? Total wait time will be this 2 minutes plus this 1 minute, because it is waiting for 1 minute to get the resource. So this is the total wait time of my request, right? So this is what we call it as total wait time of the request. Right? So total wait time of the request. So this is just a high level, like, so this is a scheduler. If the thread in the runnable queue, it is a signal wait time, right? If it is a waited list, it is a resource wait time. Okay. So these are all like, so common wait types that we have in the SQL Server, right? So before we go with, I mean, these are all common wait types that we will, so high level will touch base. Let's see. I was talking about the, so historical wait. So this is what we call it as a historical. This is what it is current, right? So if I go back, okay. So wait statistics. So this query, so all these queries are, available, like, so I will attach this to the Git repo and I'll share that Git repo, like, so don't worry, like whatever script that I'm using, and even, so whatever presentation that I'm sharing, so I'll be converted as in a PDF and I'll attach to the Git repo and I'll share that. So don't worry, whatever that I'm executing, right? So everything will be available and transparent. And this query, right? So OS wait stats. right? It tells that what are the historical weights, like the top historical weights on the system, right? So it can not in, right? The reason not in, because these are all some internal and we don't even worry about that. But anyway, like, suppose if you go and execute this sys.dm stats, weight stats, you will see around 1070. If you see here, 1070 weights, right? You cannot, I mean, you no need to worry about measure, like, so weight tabs, only few weight tabs that you will have to worry, like lock, latches, and all, right? So there are many internal or background weights it will be, right? So for example, let's say, mm, yeah, there are many, like a preemptive, like, so preemptive XE proxy, whatever it is, the sleep, right? Fail point, I don't even know, like, so there are many that even we don't know, even I don't know, right? So the broker events, right? So there are many weight events that you no need to worry when we are troubleshooting the weight stats, right? So one second, hmm, right? So this is maybe a better one. The reason it has more filters than the current. Okay, let's see. So I'm executing. Okay, let me execute this first. So if I execute, it tells that what are the historical weights, right? So historical weights, what is the wait time, right? So what is the total, so cumulative wait time since the SQL service is restarted, right? So you can see here what is the most of the wait time is 95. Of course, like this is the SOS work dispatcher, right? You don't need to worry again like this, because whenever there is a request comes in, so the SOS is nothing but SQL operating system. It will dispatch the task or the worker, right? So the work will be dispatched, right? So that is the reason you see it is on the top list, because this is what the SOS responsibility, SQL operating system or DMS, sorry, UMS responsibility, right? Preemptive exit dispatcher is basically extended event, right? So whenever there is an extended event, so there is a thread will be executed and running and preempted, right? So this is again like we don't need to worry about. There are few things that you will have to consider, like lock, checkpoint, latches, async IO, what async network IO. So these are all things is can be uh, so responsible for your slowness, can be reasonable, that you will have to look into, right? So if I just execute this, I am some kind of filter that I'm using, right? So it you will have a very few which are required, right? Lazy writer sleep. Again, like this is not needed, this is not needed, right? So lock request. Like how many requests are there? Like what are the wait counts? Total wait time, right? So how much is the total wait time? Average wait time, you know the difference, right? Total is basically so like for example, it's a average is basically a mean. Let's say for example, this one 10 minutes, next time 20 minutes, next time 30 minutes, right? A query is taking, let's say for example, next 15 minutes, next 5 minutes. So this is if you add all these wait times plus 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 plus. So if you add all these wait times, this is what we call it as a total wait time, right? So if you wanted to understand the average or the mean, then all these occurrences divided by number of occurrences, that then you will get the mean time or the average time it took, right? So maybe average time, average wait time, let's see. So average wait time, how this is calculated, the total number of tasks. That's what I told you, right? Like the number of tasks and the wait time in milliseconds, right? So what is the wait time in milliseconds? For example, let me decode if needed. So you can go through also. So let's say wait time in milliseconds, right? So W1, select start from sys.dmos wait stats, wait time in milliseconds. This is in milliseconds. Select waiting task. From sys.dmos wait stats, right? So let's take wait time, home and execute. Let's take, for example, lock mode intent exclusive. So don't worry about these. Like even if we notice that even if we talk about weights now, so in one of our sessions, like we will talk about, so different weight types. Like for example, let's say CX packet. So we will talk more in detail when we were talking about the CPU usage and high CPU utilization and all. Lock mode, this lock mode when we were talking about the log block deadlock, like so whenever we go further, we will talk more in detail, right? So we will discuss now. And while talking about the uh, lock mode, lock block deadlock, so we will talk that as well, right? It is not that like so if you talk now, we are we are ignoring. No, so we will the entire so performance tuning. So one of these will definitely touch later, right? Let's say this wait type I'll take where wait type equal to this one, right? So wait time in milliseconds, this is in a milliseconds, right? So how many wait tasks that we have? So this is what it is, the difference, right? Select, these are the wait task, I mean wait time divided by 2, right? So this will tell how much, what is the average wait in milliseconds for this particular wait, right? So this is what it is, right? I told you whatever it is, this will be divided with number of occurrences. So, right, how many waits are waiting? This is what it is waiting for, right? That is what you see. Control home, execute this. Right? So this is what the average wait time. So total wait time is mm, wait time in milliseconds. Wait time in milliseconds. Okay. The reason I'm just double checking. So I see here. This one. So this one is in seconds, I believe. 1 second. MS to seconds. Okay. So this is basically in wait time in milliseconds, Total wait time in seconds. Execute. So we can see here. So this is in the seconds, right? So that is the reason, like this is in milliseconds and this is in seconds. That is what, like, so it's divided by 1,000, like that is where, like, so that is the reason you see that total wait time is less than average wait time. Or sometimes, like, so XA dispatcher is something is different that we see. But here at least this is what I noticed in this, right? So total wait time, average wait time. Okay, whatever. So this is the signal wait time, right? Out of this weights, right? So out of this weight, this is, as I told you, right? Total weight is basically including signal and the resource wait time, right? So signal wait time is this, and the resource wait time is this, right? So resource wait time is this, and signal wait time is this. Adding these two, you will get the total wait time. So adding these two, you will get the total wait time. Right? So as I told you, resource wait time is basically waiting for some resources, and signal wait time is basically waiting for signal from the thread which is currently running it. Right? So these two we will have to consider. So what is the percentage? One sec. Right? So what is the percentage it is currently waiting for? Right? So currently total waits are. This is high level. We will talk about this. So I was talking about the current running waiting task, right? Let's say, for example, if I execute this, it tells that what are the current waiting tasks. Let's take an example. Begin tran. Begin tran. I will use Adventure Works. Begin tran. Update. Select top one. Start from sales dot sales order header. I just wanted to see sales order details. Sales order ID, product ID. Okay. Update sales order details. Set unit price equal to right. So I'm just adding something, right? So I'm adding around 10% to the unit price, right? Let's see. Where sales order ID equal to something, right? So let's say this one, right? So I'm using, um, so I will talk about the transaction types, right? For now, understand, we have three types of transactions or multiple types of transactions, right? One is implicit transaction. Can anyone tell me other transaction that we have?
Explicit.
Explicit, okay. So most of us kind of, so understanding that there are only two transaction types, right? So there is another transaction type we have, and we will talk about the difference as well. Suppose if you could give me a high level, like what is the difference, that would be helpful, right? So can you tell me like what is implicit, what is the explicit in a high level?
An implicit transaction automatically the SQL behind background begin and commit or rollback is begin and commit is done. Explicitly, we can make sure that the transaction either rolled back or committed.
Okay.
Need to mention.
Okay. So this is what?
Yes.
This is this what? Like this is what? Explicit?
Explicit.
Okay. Explicit transaction. Okay. All agree or anyone differ with the statement? With the statement, who is that? Sridhar, right?
Yes.
Sridhar mentioned. Like
Yes.
any difference? Uh-huh. What is the other type? Other one? I said three. You still feel that we have only two types of transactions?
Maybe the partial. I don't know. Just I'm guessing.
No. Okay. I'll maybe explain later. So we have something called auto commit, right? If there is an auto commit, then what is this implicit transaction, right? So there is a slight difference with implicit transaction and with the auto commit, right? So implicit transaction, you no need to mention, as Sridhar mentioned, you no need to mention begin, but you will have to mention the commit or rollback. Without that, the transaction will not be committed, right? So if it is an implicit transaction, you no need to mention the begin tran, but the commit or rollback has to be mentioned. Is this correct? Set implicit. Okay. Query option and see set implicit transactions. Okay. Okay, fine. So query and see set implicit transactions. If I set implicit transaction on, right? So you mentioned like even if I update, I have not used the begin tran and all. And if this is the case, that transaction should be committed, right? I'm executing this, right? 12 rows are affected. Open a new query. Oh, sorry. Open a new query. Select star from table where this one. I'll use the same command, same this one. Where is that? We are not getting anything, right? So this is locked or this is blocked. The reason it is blocked because of this update query, right? So this I have opened an implicit transaction. So implicit transaction, I have not used begin tran, right? And as per Sridhar mentioned, like, the transaction should be committed, right? So if this is committed, why this is blocked, right? So if I execute this, you see here, 79, the session 79, uh, sorry, the session 79 blocked session 69 is blocking by 79, right? That is what you see here. And this is the wait is waiting for. So 69 is waiting for lock to be available, right? So what is the duration? If I execute again, if I execute again, the wait duration will keep increasing, right? Execute, right? The wait duration is keep executing, right? This is where you see, this is the blocked transaction, which is blocked, and the blocking, blocking transaction is this one, right? If I go back and see, select start from sys processes where speed in. So I just ba- basically checking both the sessions, 679 comma, what is this, 69, right? So this is your this one. So this is your um open transaction, right? So you have a open transaction, the session is not yet committed. So that is where you see, right? Coming back to our discussion, so where you can find the blocking information or the current executing task, right? Current executing information, current waiting task, you will see. So if I execute again the same query, a bunch of bugs. And if I execute, you will see multiple rows in this, right? So whatever it is waiting for, right? This is the current waiting task. If I go back and get the, um, what I would say, like historical waits, this we already got, right? So historical wait, we already get that historical wait information, right? So hmm. So this will tell like what is the percentage of the signal weights, right? How much percentage? Let's say, for example, uh, what is the total wait time and how much percentage signal weight? The thread is waiting for signals, right? So this is the percentage of total weights. That is currently 5%. The threads are waiting for CPU to be available. So this is the current signal weights, so right, whatever we see here. This is again like the same thing that we talked earlier, right? What is the schedule? How many current tasks are assigned to particular scheduler? On an average, you will see the same value, same number of threads on each individual schedulers, right? So that is what we see here. Now go back to our discussion. Right? So these are all a few common weight types, right? So it is not restricted only these two. You might end up seeing some different weight types as well, right? But these are all a few common weight types that we have, right? So can anyone tell me any of these weight types that you might have seen or understanding, right? Or you have something else in your mind, right? So you might see, you might have noticed some other weight types, whatever it is. So can one of you or anyone tell me if you already know one of these weight types, and if you know just a one line, what it is? I'm sure like one of you must be saying majority of these weights. Okay, fine. So let's go with first CX packet. So what does it mean by CX packet? Is the query is running and waiting for parallel execution. I mean, the query is running parallelly, right? So the query is running parallelly. So we will talk about the query execution, the CX packet in parallelism, and just a high level, I'll tell. Okay, a simple query, select star from table. And this query, let's say it is going for parallel execution, right? Parallel execution is nothing but multiple threads will be, so assigned to this particular task. Multiple threads will be assigned to this particular task so that this task will go ahead and execute on multiple CPUs, right? This one CPU, this is another CPU, another CPU, and the CPU. So this will be assigned multiple threads, thread 1, thread 2, thread 3, 4, right? So there are multiple threads will be assigned and execute on the CPU. So how basically it will be distributed? Let's say, for example, select star from table. It needs 100 pages. I mean, just giving a simple example. Don't quote exact thing it happens, but it happens when it is, so this is one of the scenario that it uh, takes care of, right? Let's say there are 100 pages this table has to proceed with. 100 pages, this query should be satisfied. This 100 pages, 4 threads assigned. So these 4 threads will be equally divided the workload. Let's say this is one thread will be processing 50 pages, 25 pages. Another thread will be processing 25 pages. Likewise, whatever number of threads will be divided the workload equally and distribute the workload to proceed further. Now, what will happen? There is a parent thread P0 and there will be a multiple child threads will be available, right? So there will be one parent thread and one child threads. Thread 0, let's say thread 1, 2, 3, 4. So what it happens, the parent thread responsibility is to distribute the workload. And the parent thread responsibility is to gather the workload from multiple child threads, right? Parent thread responsibility is distribute the load and gather the load, gather the workload because this process 25 pages. This process 25 pages. This is 25. This is 25, right? Each thread processing 25 pages, but I need the data for 100 pages. This parent thread responsibility is to synchronize across all the threads and get the data, right? So parent thread responsibility is to make sure that all threads are synchronized to receive the data or represent or generate the result set. If one of the thread is delay, right? If one of the thread is delay, the entire query will be waiting. So the representation of the thread, parallel thread execution and synchronization delay or latency, it will set as CX packet. It will set as CX packet. I don't know if there is an acronym or if there is any full form or anything for the CX packet, but this is the behavior, right? So if it is multiple threads and during the synchronization, it will be delay. One of the thread will be delay. So it is basically telling that the parent thread is distributed the workload, and once the parent thread receives the workload from all the child thread, then only the result set will be displayed. So this is the representation the query is going for parallel execution. So that is what we see here, CX packet or even CX consumer, right? So CX consumer is the same thing, right? So I think starting from 2016, this CX consumer thread CX consumer wait, that is waiting. CX consumer is basically, CX packet is basically a parent thread is waiting for some resources. CX consumer is basically a individual thread is taking time to synchronize with each other, right? This also has to synchronize with this multiple threads has to be synchronized, right? So this is the this is the wait types of CX packet and CX consumer. Parallelism wait types basically. For example, let me see. I'll kill the sessions. Right? I'll roll back these sessions. As soon as I roll back, 67, 69 got completed. Right? The unit price has not changed because the unit price, the session is rolled back. Right? What is auto commit is something that the transaction will be committed automatically, right? You no need to provide the implicit, and you no need to provide the begin, you no need to even provide the commit, right? But if it is an implicit transaction, the begin is not needed, commit is required or rollback is required, like this, right? Query, this will be at the transactional level, right? So that is the reason I tried to set implicit on. Is this wrong? I don't. Correct only, right? Set is spelling wrong. That's what I said. Oh, okay. Implicit transactions. What is wrong in this?
CA,
What is that?
Transactions.
TRANCA. You have
Oh,
SC.
let's see. That's what. Okay, cool. Yeah. So this is what it is, right? So this is set implicit transaction is always at the transactional level. So it's not at, um, it's not a like, so all the queries that we'll be using. So whatever transaction that you want to use, you will have to set implicit transaction on, right? In the application. So there are applications where by default it will be set to implicit transaction. So you will have to be very cautious when you are executing a query, right? So there are chances, right? So they just execute a query and they might think that, okay, the transaction might be committed, right? So if the transaction is committed, sorry, if the transaction is an implicit transaction, even if the query gets completed, that will not be closed. That will have to close, or we will have to ask them to close explicitly. Live example. There is one client tool called DB Viewer, DBEV, whatever, so DB Viewer, I don't, DB Viewer is the tool, right? It is a client tool, right? Like how we have SSMS, DB Viewer is a tool where they can connect to the database and multiple RDBMS, right? MySQL, Postgres, SQL Server, like multiple databases that they can connect using the DBVR tool. So they connected in my environment. So they connected and they executed sp underscore cdc enable on the table, right? So sp underscore cdc enable whatever table, right? They enable the cdc and so the cdc command got executed successfully. What happened? This cdc enable cdc on table, it is a ddl command. It executes certain ddl operations at the SQL server and it locks the complete table because it is tracking the cdc and locks the entire table. So if this is the case, and as I said, right, DB viewer by default, it is going for an implicit transaction. It's like this, right? So whatever query options that I have, so by default, it is going for implicit transaction for that queries. Whatever queries coming in, what happened? This one, DDL command, it locked the complete table. Whatever queries which are coming in and execute on the table, all are blocked, all were blocked, right? So everything got blocked and that caused the thread exhaustion, right? Everything is blocked and waiting for, so waiting for lock, blocking everything. And that is called thread exhaustion, right? So we don't have enough threads to take any of the request, right? We cannot even connect to the SQL server and execute any of the queries because threads are exhausted. So in that case, what option that we have? We can enable open a CDC and DAC and execute some comments, right? How many queries that you can keep killing, right? So everything is keep blocking each other, right? Even if we kill one transaction, there are application, right? So application is spawning connections, right? It is in the queue, so everything will keep generating, right? What we did, we had to trigger a HA failover. This was Azure SQL, right? Pass. We had to fail over the resource from the PowerShell or the automation that I have. So we had to fail over, then it it recovered the database, right? So this is how you'll have to very cautious when you notice any of the weights and if the thread, any of the weights, especially blocking, and if it is an implicit transaction, you will have to make sure that they'll have to close the connection.
Quick question, Chandru.
Mm.
For the CDC command, as what I don't know whether my understanding is right or not. Is it that for few commands, even though we are not mentioning implicit, depending upon commands, it will take the implicit transaction comes into picture?
No. So, okay. No. So CDC is just an example that I was talking. So doesn't matter either it is a CDC or whatever it is. And if you use this implicit transaction, the transaction is open until and unless you explicitly commit the transaction or roll back the transaction.
Yeah, so it is nothing to do with some specific terms or queries. It automatically sets into implicit transaction. This is not the case, right?
This is
We
not the
need to
case. No. So
mention.
application has to mention, or query level you will have to, if you mention, then only it is going for an implicit transaction.
Okay. The next question is, in the case you pass in the pass situation,
Mm,
high availability, you did the switchover.
mm,
So it means that for the current executed session,
mm.
the session will be terminated
Correct.
and this particular session will be rolled back.
Mm,
That is the case?
mm. Correct. Whatever queries which are which were executing, everything will be kicked out, killed and aborted or terminated, and it will be going for rollback. Yes.
Instead of killing the lead, the main block, instead of switching over,
Mm.
blocking the main one will be there. is it the better option or switchover is a better option?
So what is your option? What you will do in that case?
With
What option
DAC,
that you have?
with the DAC connection, I think we have administration to kill the session. I don't know. I don't have real-time experience. I'm
No,
just
no, no. You tell me, like, what is your thought process is correct, right? So you will open a connection DAC query, and you
yes,
will try killing the lead blocker. Let's
yes.
say CDC is the lead blocker. In this example, don't quote this is only for CDC. Any query that you execute implicit transaction would be the same. So CDC transaction is 100, for example. This is blocking 10 other sessions, and there can be other sessions also blocking other queries, other sessions also blocking other queries. So it is not that only the CDC can be a lead blocker. Let's say even if it is CDC is a lead blocker, right? So if the CDC is lead blocker, then it might, I mean, so whatever the user query which is coming in, right? So the reason that we had to switch over, because I think even CDC, I mean even DAC connection. So the query we were not able to execute, like we were not able to connect and execute, right? So even DAC connection we connected, but even we tried to kill, that was not been killed properly. That was not been aborted, right? So the queries will keep executing on the SQL, and it is kind of sluggish, where we were not able to open any of the connections to the database.
Okay. Theoretically, the first step is DAC. Try
First
to
step,
kill
if you are
the.
able to open a DAC connection and close the lead blocker,
Got
that
it.
is the first step that you will have to take.
There could be a number of reasons where we are not in a position to kill it, or there is no response. So in such cases, we maybe switch over to the other
Node,
available
correct,
standby
correct.
server. Okay.
Yeah. Um, right. Let's see. New query. Select star from. mm, 1 second. Select star from sales dot sales history. If I take this sales order details. Let's see. Begin tran. Set. Where sales order ID equal to this one. Let's see. Right, 22 rows are updated for this. Select star from sales dot Sales order detail. I'm executing in multiple sessions. Let's see this. I'll close this. Lock mode. Okay. So I'm just trying to show the. So don't worry what I'm using. So I'll just I'll talk this on this. So whatever query hint that I'm using, I'll talk this later. So don't worry about that. 70 speed equal to 70. Whatever. Select start from some option, incorrect syntax. So this one, whatever I'm executing, so the joins, that also we will talk. So don't worry, just I'm joining multiple tables, right? So uh, that's it. Okay, fine. So let's see, async network IO. I thought of showing that, like, so CX packet waits. Maybe I was not able to. I'll check that. I should have some examples, but I'll see that. Okay. So if you see that async network IO. So async network IO, common misconception or misunderstanding is it is a network issue, right? So it is basically a not network issue. So even if I am executing this from the SSMS, right? So this is I'm running from local SQL installed, local SSMS installed. I'm executing this query locally, right? Even though if I'm executing this locally, that is what I see async network IO, right? So the reason async network IO is, so you are basically fetching. You are basically fetching more and more data, right? Since you were fetching more data, that is what we see that async network IO waits, right? It can be a network issue. Like I'm not saying that it is not a network issue. Suppose if it is network issue and if you are executing from the client machine and that needs more data, so that also can cause that issue. So I'm not denying that there is a network issue, but it is more on like, so client fetch where client is requesting more data. Let's say client is the query is bad. For example, the query is not optimal. And if the query is not optimal and they are executing more and more like, so rows or reading more data or updating more data or whatever operation that they are performing is working on more data. So in that case that you will see async network IO. There is no straightforward or there is no settings that we can go ahead and change to fix that issue. So more on like, so they will have to change the query behavior or the application query has to be fine tuned so that it will pull or perform operation on only a such a set of data instead of, so the huge amount of data that we have, right? So if I go back here, okay, whatever. So this is the same thing, right? So even if I'm executing, so you will see, so this is OS wait stat. So it tells like what is the historical async wait type. So it doesn't work now. So I haven't mentioned, but async network IO is basically if the client is fetching more and more data, so it doesn't matter either it is a network issue or it is a you are executing from SQL Management Studio or even locally that you are executing. And if you are fetching more data, that you will see async network IO. So as soon as the query gets completed, you will see miscellaneous, right? So it is not waiting, it is not nothing, right? So the wait type is nothing, like you don't see any of the session is currently sleeping, currently it is in sleeping state, right? Remember, even if it is sleeping state, it is dangerous or blocking other sessions that we were talking about the implicit transaction, but you will have to check that if it is open or not, right? So this is the CX packet and the network IO. SOS scheduler yield. So this is what we have been talking, right? SOS is nothing but SQL operating system is waiting for the thread to be yielded, right? So what does it mean? If the thread is currently running on the CPU and there are other threads will be in the runnable queue, right? So the threads will be in the runnable queue. How SQL engine understand, okay, this is in runnable queue and I'll have to go ahead and execute. One is a signal, definitely. Second thing, the thread which is currently in the runnable queue, the wait type, the wait will be set as SYS scheduler yield, right? The wait type that is set for the thread which is currently in the runnable queue and waiting for scheduler to be yielded, waiting for whatever thread which is currently executing on the CPU to yield. Yield is nothing but come out of CPU. So until that, it will be marking as SOS scheduler yield, right? So it will be adding as SOS scheduler yield. So go back here. And if I execute, so this will be in a while loop, right? So this executes in a while loop, so it will keep executing. If I go back here, and just keep executing. So this is basically I'll have to execute in some multiple threads so that you will see that. Yeah. Fine. So even if you see here, select start from sys.dm exec request. This is just an example, right? SYS scheduler yield, last wait time was SYS scheduler yield. So last wait time as in, so what is the current wait time for this query was runnable. I mean, so current status is runnable. So that changed to sleeping. That's fine. So when the query initiated, so it will be marking as SYS scheduler yield if it is in the runnable queue, right? So when the query is in the runnable queue, the wait type that we see is SYS scheduler yield. So when to worry about the SYS scheduler yield? So are we need to worry or not? Because we will have to worry if the high number of workers, high number of threads are waiting for SOS scheduler yield, right? So high number of threads, right? So we have something here. High signal weight. Right? So if you see here, the number of based on number of requests that we get, based on number of tasks that we have, right? If you see here, the weight signal weight, right? So currently 5% is the total signal weight, right? So on this server, ideal system, right? If the weight type, right? So total weights, right? So signal weights is basically if you have a high signal weight, you will see that high number of SOS scheduler yields, right? So in any system that you notice, right? So you will basically see SOS scheduler yield is a common weight because the thread has to be waiting for CPU to be available because every thread cannot go and execute on the CPU. So when to worry, suppose if the percentage wait time is more than 15%. I mean, just a thumb rule, it can be more or less depends on the workload that I'm executing on the CPU, on the system. But if it is more than 15% of the signal wait time, right? So in the total wait time, right? So if I have a 15% and more signal wait time, then it can be considered as noticeable because this is more waiting for CPU to be available. So in that case, you can assume that, okay, it doesn't have enough CPU to process your request. So in that case, we will have to consider increasing the number of CPUs, increasing the number of CPUs. This limit is not hard. I mean, it is not like a thumb rule that you will have to monitor only 15%. But if you have a high number of task waiting and high number of signal wait time that you see, high percentage of signal wait time that you see, then you will consider increasing the CPU cycle, CPU cores. Let's say you have 4 CPUs here. And as I told you, let's say the number of tasks will be distributed in a round robin. Let's say 10, 10, 10, 10, like that it is distributed. It was distributed. Now, one thread executed, currently executing. Doesn't mean that SOS scheduler yield only if the query is running longer. So SOS scheduler yield will be if the number of tasks in your CPU core is increased. Let's say, for example, the workload increased. Let's say 100 tasks waiting on this CPU. One query is executing here. One thread is executing on the CPU. Next thread will be executing. Next thread will be executing. So likewise, when this 100 thread will get a chance, right? So if the query is workload is more, even if the query is executing within a few seconds or few milliseconds, the last threads in the queue, threads in the end of the queue will have more wait time, right? So that is the reason if you see that if the signal wait time is more, right? So definitely 100 thread will have a higher signal wait time because it is keep waiting for signal to be, it is keep waiting for thread to be signaled, right? for this particular CPU. Likewise, other CPUs also will have the similar behavior. Right, so this is just my I'm just thinking like maybe it can be depends on the workload that you have on the system, right? But if it is more than 10-15%, it is considered as noticeable that we will have to analyze the workers, the number of tasks created, number of tasks in the runnable queue, and if there is any workload increased recently, right? So you will have to analyze the historical workload. Let's say, for example, today I noticed this behavior. How many threads, how many tasks were created yesterday, how many transactions were executed yesterday, and how many transactions today. So that trend you will have to analyze. Suppose if you have any monitoring solution, or if you have any tracking mechanism so that you can track the query workload and all, that is easy for you to track the historical workload to understand what happened yesterday and what is today, right? That is SOS scheduler yield. So thread pool wait types. Again, so same I was talking, right? CDC, enabling CDC. So if thread pool is basically a pool of threads, right? So you will have some kind of uh, uh, threads in the pool. Let's say, for example, 100 threads in a pool or 200 threads in a pool, whatever it is, right? So if you don't have enough threads to execute your workload, then you will see the sessions are in pending and it will be waiting for thread to be available. So the wait type is set to thread pool. The wait type will be set to thread pool. So we will talk about, so the threads supported for the particular based on particular CPUs, right? So there is some calculation, right? So calculation for the number of threads, parallel threads. Remember parallel threads. Right? If it is 4 CPUs, there is a calculation, right? How many threads will be for particular system. So parallel threads can be supported for particular system. It depends on the number of CPUs. Suppose if it is 4 CPUs, it will be 512 threads. If it is 8 CPUs, the calculation will be different based on this calculation. For example, let's say if it is this is the formula, let's say, right? So if it is 8 CPUs, right? So the default max worker, what is the default max worker? Is your, just using select query, select default max. Okay. Default max worker is 512 for any system, right? By default, it will be 512. So logical CPUs, let's say I have 8 CPUs. This is the calculation. This is the calculation workers per CPU. What is this calculation? Why is this? System with more than 4 CPUs is greater than 512 number of logical process into 16. Okay. So the calculation, this worker per CPU is static if it is 4 CPUs or less than equal to 64 CPUs, right? Between these two, the calculation is this. Right? So if it is 64-bit, definitely it is obviously like we all using the 64-bit. We are not using 32-bit anymore. If it is between, the number of cores are between this, the calculation is this. If it is more than 64 CPUs, 64 V cores, the calculation will be, I think this is 32 threads per CPU, right? This is the calculation, simple calculation. So if I consider like I have 8 CPUs, this will be pi 12 select pi 12 plus number of logical processors are 8, right? 8 minus 4 into 16. So this is the calculation that will be working 576 if it is 8 CPUs, right? So if it is 16 CPUs, same thing, select 16 minus 4 into 16 will be your total worker threads, parallel worker threads that can be supported for this query, right? Suppose if parallel workers, one of the scenario is blocking, right? So as I told you, right, CDC, by enabling CDC without proper commit, that is just an example. Don't quote that it is only for CDC. So any transaction that you execute, and if the transaction is not closed, either commit or rollback, the transaction is open, all other queries which are executed will be locked if there is a incompatible lock, right? We will talk about the locking and all. And if that is the case, every query will be waiting and your max worker limit will be reached. Whatever max limit will be reached, then you will not be able to open any of the connections to the SQL Server. Right, so this is things. This is just for testing, right? So testing, like I set the max degree of parallelism to, sorry, max worker to one. This is how many CPUs that I have? I have 4, right? So I'll just go here. I have 4 CPUs. Based on 4 CPUs, what would be the, so the default workers is 512. But what for testing purpose, I have configured max worker threads data. Max worker threads, right? All right. Max worker threads, right? So I have configured. So this can be configurable, but if you configure this, do not do it in production environment, especially because if you configure this a higher or lower value, that can um, cause the issue, right? Suppose if you configure higher value, maybe for just a time being that maybe it can sustain, but if you increase this value, right? If the system cannot support where how the threads will be created, right? If the system itself cannot support, right? So I have a 4 CPUs and the max worker is this, right? If that is the case, how is this will be set, right? 0 reconfigure. Let's see if I can set. Okay, let's see what will be the right. So 0. Select start from sys dot os info. dm os info, right? Sys dot dm os. DMVs info. DMVs this info. It tells that what is my max worker count on this system, right? This tells what is my max worker count on this system. Even if you open this DMV and execute this query, and it tells that what is your max worker based on your system. Suppose if I set it to 100, for example, right? So 100 is not valid value because the minimum is 128. Where did you get that minimum value? And if you execute this query alone, you see here minimum is 128, right? Minimum is 128. And if you execute this, this should work. And if you see that sys.dmos sysinfo, again, this is it doesn't even worry about how many CPUs that you have. It will check whatever you configure the max worker limit for this query, and it will set the value, right? So this is what the max worker value is, right? For example, hmm. So two scenarios where the query, the worker thread can worker limit can cross, right? One is one is locking. Second one is, can anyone guess like what would be the second reason all threads will be exhausted? Just a guess, right? Or if you are already have a little idea. So what other situation? Thread exhaustion is basically you don't have enough worker threads. Everything is all threads are busy, right? One is locking. So locking or blocking, whatever it is. So all threads are busy with to get the resource or waits, right? So what can be other reason the thread can be exhausted?
The number of transactions exceeded the capacity of threads.
Okay. So number of transactions increased. Okay. So if number of transactions are increased, okay. So you want to elaborate anything like how this number of transactions will be causing the thread exhaustion? Because number of transaction, one transaction is coming in and executing, and the thread can be released and going back
Yes,
to the
correct.
other transaction.
Yeah.
Okay. So only if all threads are busy. Let's say, for example, I have 4 CPUs, 512 parallel workload, parallel threads, right? So this is 512 parallel threads are not processing anything. So simultaneously or concurrent workers are not processing. So you don't have any more threads to take your responsibility or take your request, right? So one reason is blocking. Second reason, what could be the reason for this? The all threads are exhausted at the same time. So parallelly. So I literally answered.
Yeah, during parallelism,
Hmm,
if the threads are busy during parallelism
hmm,
and the threads are exhausted, so no
hmm,
more incoming transaction will be, it cannot allocate more thread for in that case, right?
hmm. Correct. So that is parallelism. Because if there is a high parallelism, let's say there are chances, depends on the query complexity, one query can go to any number of parallel threads. Any number of threads, right? So the reason I mentioned any number of threads with respect to whatever CPU count that I have. So currently I have 4 CPUs. With respect to CPU count that I have, if the query is complex, even it can go any number of any number of threads, right? The parallel threads. We will talk more about parallelism in query performance and all. Remember, parallelism is not based on number of CPUs or not based on the query. It's based on number of operators, right? Don't worry, what is this operator? Operator is basically whenever you see the execution plan, whenever you see execution plan, each icon, each this one is represented one operator, right? Sorry. So based on the query complexity, right? Each operator can go maximum as per the number of CPUs. Let's say this operator can go to the 4 threads. This can go to the 4 threads. Likewise, it depends on number of operators that we have. Each operator can spawn as many as threads possible, right? As many as in, like, for example, this query can go for 4, this can go for 4, this can go for 4, this can go for 4. Likewise, it can spawn across each operator, and it can be as many as it can, as many as it can go, right? So that is the reason I don't have a hard limit, like, so how many threads the query can spawn, or how many threads the query will be spawned. I cannot tell until and unless your max degree of parallelism is set to 1. If it is 1, the query will be going for a single thread, right? We will talk this in the query performance. For now, understand one of these cases, the threads will be exhausted and it will be waiting for thread pool, right? So because we don't have enough threads in the available worker threads, you don't have available worker threads in the pool, right? So you will have to identify the solution is you'll have to identify the blocking and close the lock blocker. Close the head blocker. If it is parallelism, and you will have to identify the query which is consuming more number of threads, and you will have to uh, take some action, either so setting the max degree of parallelism or setting the cost threshold for parallelism. We will talk all this in query performance. Locking, that we all know. So locking is basically there are some two transactions. One is update, another one is select, right? If you already aware of um, we will talk about the transactions like isolation levels. So isolation level, we will talk about lock blocking deadlock. So during that, we will talk about the isolation, right? But if you have these two things, right? One is updating. So let's say, for example, you're updating your name from ABC to XYZ, right? So this is not yet committed. If you're trying to read the data and display the data in a report, for example, you are sending this report to business analyst, saying that these many people I have in my team, or like just an example, like you're pulling the report and sending to some stakeholders, right? Saying that this is the report, these are the members that I have, right? What if you give a different wrong result? Then it is kind of so completely it's a kind of mess, right? If you are giving a wrong input or wrong output. For that reason, this will hold an exclusive lock so that no other transaction or no other users would be accessing your data until and unless that is committed. If you are executing a select query, that requests for a shared lock. I will talk about the locking and all, don't worry. So it will be exclusively locking that particular row or particular table. Then you would not be able to open any of the transaction or connection to that particular row until and unless that is committed, right? Until and unless that is committed, it will be waiting for certain lock. This lock star I mentioned, it depends on what it is waiting for. It can be a shared, it can be an exclusive, it can be update, whatever it is. It depends on, we will talk that later. I mean, later as in like when we were talking about the lock blocking deadlocks, right? So when we say sys.dmvs wait stats, where wait type like LCK. Right? These are all logs it is. Right? So different logs, but the behavior is same. If it is incompatible logs, it will be waiting for some response. It will be waiting for the connection to be closed or the transaction to be closed. Right? We will talk that later. Okay. I'll stop here. We will talk, and maybe I'll uh, show you some demo as well. Like so what so what queries that you are executing, you will get these weights, and whatever page last write log that we will talk, right? So write log, we already have just a high level. Write log is whenever you are executing a transaction, that initially it will write into the transactional log, log cache into the memory, and then it will write into the log file, right? Suppose if you have a high number of transactions executed, either it is committed or if the transaction log cache is full, right? That will write into the transaction log file. So while writing into the transaction log file, that you will see it is a write log waits, right? Writes related to issue when writing into the transaction log file. Delay durability reduces the write log, but there is a drawback in delay durability. If you have restarted the SQL, whatever transactions which is committed and not written to the transaction log file will be flushed out, right? So this is what it is, right? So this is resources. This is memory weights, and this is for the always on HIDR sync commit. So we will talk these in next class, right? Any questions? Any questions?
Sir, in case of actually the in data cache, the information is handled in pages, right? The complete pages is taken from the data MDF
Correct.
data file, and it is modified in data cache.
Correct.
In of course, sir, for log file, it is not. It is like virtual files. So in oh, sorry. My question is log cache. So this is it is all. This is also not pages, right? It is.
Yeah, listen, log sequence number. So it will be a log series of logs. It is kind of so you have a error log, for example, just an example. Again, don't quote that this is error log and SQL log file is same. Error log, you'll have a series of logs, right? Each line you will have that timestamp, and you will have that each line it will be written. So likewise, so even transaction log file also, you will have that sequence number for each and every transaction that we perform on the database. Let's say it can be a update, it can be a delete, it can be insert, everything will be written in a one row, and kind of so log sequence number that will be flushed into the transaction log file as soon as the transaction is committed. So
Okay.
transaction
Once
one is
after.
opened, you'll have series of modifications, for example, in this transaction. So you'll have each transaction is a LSN, and it will be mapped to LSN plus transaction number, so that everything will be flushed out once the transaction is committed. You're asking something.
Yeah, once the transaction is completed, this particular LS record, whatever may be LSN plus transaction details, they are flushed out from log cache. Is
Correct.
it?
Correct. So there are two scenarios, as I said, right? So one is when the transaction is completed. Second one is one log cache is full, right? So that is, I think 64 KB, whatever it is, log cache is full.
Yeah,
With
yeah,
respect to the
okay.
transaction is committed or not, it will be flushed to the transaction log file.
Okay, actually the confusion was how log cache behavior and log file. Like log file is again, it is a different. So I got confused between this one, and I recollected that The mechanism you already explained in the last class, I think. The 64 kBA, either the checkpoint occurs at 64 kBA or committed transaction, right? Thank you.
Correct. Sure. No problem. And one thing you are asking about the resource that you are talking, right? So checkpoint or something. Checkpoint plus um, mm, 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 mm. Right? So you can go through. This is good. Suppose if you don't see anything in Microsoft, so this is good blog post that you can read through, right? All dirty page file pages data written to the disk, all pages that have changed in the memory since they were read from the disk, since the last point, regardless of the state of the transaction that made the change, right? So regardless, whatever the state of the transaction, either the transaction is committed or not committed. So the transaction, the pages is marked as dirty and those pages will be moved to the storage, right?
Yeah. Thank you very much. Can you, it is
I
SQL
pasted here in the chat.
skills. Okay.
I pasted here in the group chat, Zoom chat.
Thank you, sir.
Sure, no problem. So I'll stop here. And if you have any questions, so we can make a note and we can talk in the next class. Okay, thank you all. See you.